now. So next we're going to talk about assembly techniques. So this is going to talk about our workstation setup and safety, because you can hurt yourself soldering. I'm just going to keep saying it over and over so people can hopefully be really careful of what their hands are doing near hot irons, and then the soldering tutorial. And then again, Josh is going to follow up with actually showing you how not to burn yourself. So the workstation setup, I am a big believer in a clean and organized workstation. And it's just really nice to have that area clean, free of debris, because there's little, if you have a bunch of metal pieces from old resistors and things you've been cutting all underneath you and you place your board into that area, your board can pick up those pieces, or somehow something goes into your board. And again, when we have those little integrated circuits and their pins are close to each other, it's really easy to cause a short across two pins with junk that you have put accidentally onto the board.
Backing off up of that, I've actually seen with a past team, I won't reveal which university it was, actually was putting together a prototype board, and they had like leads on the table, and their board wasn't working, and I ended up picking up, looking at it, removed one lead of like an old resistor and gave it back to them, and it worked.
Yes.
Those kind of things can happen. So it's actually very important that you actually set up and make sure you keep a clean workstation.
Yeah, yeah. And they're lucky, I would say, that their board worked, because oftentimes you've done some major damage to something, and it's, yeah. Pay attention. I'm just going to make a little note too. Whenever you need to connect something to your board, and just what we're talking about, like you're in a hurry, you're trying to grab a wire because you realize, oh my gosh, I need to connect these 2 points. Make sure your wire is insulated. I've heard a separate story of like a robotics team at the last minute, they needed to connect two things on their board, and they actually picked up some wick, which we're going to talk about later. It's a metal braid, and just used it as a way to connect 2 points, and then they ended up, it shorted across something, and they destroyed their robot at the last moment after they had been working on it all semester or years. I don't know what it was. Anyway, just be aware, if it's a metal piece and it's hovering anywhere near your circuit board, and it sticks, and then you turn it on, it can cause a short. So we're just gonna keep pushing that idea too. Hopefully you think about it. Okay, you also see on here that there are some safety glasses. I would highly recommend safety glasses, and Josh is going to demonstrate why, but whenever you're clipping the leads, those leads can fly away, and it can definitely, if you have that board angled incorrectly, it can hit your face, as well as if you are quickly remove the soldering iron, it can throw the solder up. So try to have smooth movements whenever you're doing it, but that can also, you don't want it to get into your eye. So again, safety glasses, the meter, the multimeter, it's always good to have your meter. The light source is really important. Some people, I like to use an actual microscope to solder, especially surface mount parts. So they have like different magnifier glasses you can wear, different things that people use. Needle nose pliers, tweezers, the desolder gun, solder, ESD mat, and the wire cutters. And so we, hopefully these things you'll have tonight or whenever you do the tutorial. Okay, so check on the time. Okay, we're good on time. So safety comes first. So situational awareness is key. So be mindful of where you are and what hazards are around you. The safety glasses, again, I would wear them. Hindsight is only 20/20 if you have both your eyes, so wear them. Soldering irons can get hot in excess of 650 degrees Fahrenheit. So that is enough to burn your skin. So it's really important to be aware of that. Be aware when they are on. If somebody's showing you something, don't use a soldering iron to point to something on your board while you're showing something to somebody. So just little things like that.
Yeah, really, don't do that. I've gotten burned from someone doing that before. It's not fun.
Yes, yes. And also be aware that whenever you're heating these components, they stay hot several, maybe even minutes after you solder something. So grabbing something immediately after it's soldered, it's most likely going to be hot, and you can burn your hands in that way as well as through the soldering irons. And this is in particular true if anybody has ever used a heat shrink gun, which is basically, it looks like a hair dryer, but it's used to shrink basically some tubing that goes around wires. I have been burned so many times by, you know, students just handing me their connector that they just finished for me to look at, which is great. I was happy to do that, but then I'm not paying attention. They had just heated it and I touch it and immediately get burned that way as well. So important. And then they have, you know, it takes 1 amp of electricity to cause fatal heart irregularities. I think it's actually less than that, but yes, just be aware. So for the components, we talked about this a little bit. You can use the ESD discharge, you know, electrostatic discharge. They can destroy the electrical components. So you want to leave the components in the static shielding bags until you're ready for use. And you'll often find that when you order the IC chips or you get them, they're typically in some kind of ESD protection bag. So keep them in there. The ESD strap prevents you from shocking the components with, so it basically kind of keeps you at a potential that is safe. And then excessive heating from soldering can harm electrical components, and we're going to be showing you different things with that. So situational awareness is key. So they have these kind of funny pictures that just give you an idea. Be mindful of where you are and where the hot items are. Make sure you get your hair out of the way. I typically put my hair up. And then eye protection is important. And there's also lead in the solder, so wash your hands afterwards. And oftentimes, if you're soldering in a professional environment, there might even be some kind of vacuum or hood that people use in order to kind of disperse the fumes from right around the area. So
yeah, one thing I've also seen people do, because the smoke itself can be irritating to the eyes, is I've also seen people just grab like a small personal fan and just turn it on at one side and just blow the smoke away.
Yeah, that's a great idea. So inspect all the components before and after soldering, because you don't want to install something and then realize, oh no, the component was damaged or something was very obviously wrong. And then now you have to desolder it, which is not great. Components should be as close to the board as possible without stressing the leads. And I would say that they should also really be flat. So it's easy when you're first starting to not pay attention to keeping them flat against the board, and then you get the components are offset, and it's really bad with connectors whenever that happens. So orient components so that their value markings can be easily read after installation. So you can have like the resistor color bands all reading in the same direction. When the IC chips are to be soldered directly onto the circuit boards, their pins are often slightly too far apart and must be gently aligned. So you know, you make sure to be grounded when you're doing that. Oftentimes there are, typically in those cases you really want to use a socket, but then you have to make sure that if you are using a socket and then you put the IC chip in, that your chip is secure. So often, like at my old job, we used to put tie wraps around those parts to ensure that they're not going to come out whenever you're, you know, your device is being driven to Palestine, Texas, or whenever it goes right before launching a balloon, that your IC chip that was in a socket comes loose, one of the pins. It would be very bad. So soldering tips, it's easier to add solder or remelt it versus remove it. And that's a very counterintuitive situation, especially whenever we're going to be showing you how to remove solder. So I always say when we want to desolder or remove solder, you add solder. A little counterintuitive. And that's just basically because once the solder melts and starts kind of flowing, then everything around it flows, versus when you're just trying to remove it and you don't have the heat transfer happening, then it's really difficult. It's easier to solder using the side of the iron rather than just the tip. Sometimes like the tip too, if you have a bad tip, that can cause heat to not transfer to the end if you're starting to have problems. There's also many different types of tips out there. Some are thicker, some are thin. Depending on your application, you can order the right part if you're doing a lot of something. Make sure the iron is heating, both the pad and the pin. Those are those 3 points. There's going to be several things. There's going to be the pad we're trying to heat. There's going to be the component or pin or whatever it is that we're going to try to connect, those two. And then we have the solder and we have the iron. All of those things need to connect together. Good lighting is important. Install the smaller components first, and then work your way to the larger components. So typically you do like the resistors, capacitors, those kind of things first, and then you move on to connectors. And then install the integrated ICs into sockets, not directly on the board, but then I would use a tie wrap or something to ensure that that IC cannot come out of that socket. So the through hole component, so this looks like, so I'm just looking at this. I don't know for sure. It's a diode. And the reason I say it's a diode is because it has that line across it by the 1. And that tells me that that's a negative. That should be the negative side of that circuit, and then the other side should be the positive side. So when you're doing board layout, always think about your user, somebody else that's not you, that's coming behind you to solder components. Do they understand, without having to go look at a schematic, what the polarization should be? So be thinking of those other people that are going to be using your board and making sure they're aware of where things are at. You can also see that the component is on there. It says D301. So that means if I want to look and see what is that thing, I can go look at the schematic and say, oh, it connects to here, here, and here. And if I need to probe on the board in order to do troubleshooting, I can use the schematic and actually figure out how that's connected to everything and check to make sure like the right voltage or the right signals are coming out those other components. The through hole components, again, they're showing you down here at the bottom with the polarity. Let's see. So this U101, you can see that these all look like circles except for this one. And so this is, again, in the layout process that this person who did the board layout is trying to let you know that that's pin 1 indicator. And if you remember last week, just to go over it again, that's pin 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so on your schematic, that might be shown in different orientations, but on the board, that's the way the ordering goes, and that's how the pins are connected.
You also can check, if you also look at the PCB board right there, you'll also see a small little notch in the silk screen.
Yeah.
That is also another common way that people will mark which side is up on a PCB board, and usually it's if you see the notch, it will be to the left of the notch where pin 1 is.
Yeah, yeah. And then on the chip itself, so they've got it into a socket here, I can see, and then they've put the chip in. So the beauty of the socket is it allows you to remove these chips without having to unsolder the part. And it also allows the part not to be soldered, which may help with lasting it for a long time. I can tell you that this does not have, right now, this particular part is not latched down with a tie wrap or something, which is what I would do if I were going to fly this on a balloon. But here, there's also that circle, that edge circle in the part, that's again indicating pin 1. So we're just trying to get you used to pin 1, pin 1, pin 1, because there's going to be a time where you're going to hook one of these backwards and you're going to say, oh yeah, that's right, let me check pin 1. So whenever you're using these through hole components with the resistors, you can use the lead bending jig if it's available. So this is really nice if you have one of these around, but if you don't worry about it. You can still bend it with your hand. It's okay. If you bend it like 10 times, then remember last time we talked about mechanical stressing of those leads, and maybe get a new resistor because you've bent it so many times and it might have caused damage to the lead. Yeah. So
the lead, there should be a one of these lead bending jigs in your miscellaneous parts kits.
Awesome. Great. I wish I had that for a long time ago. They're so great. Okay. So the soldering tutorial, so we're just going to talk about that now, about how do you solder. And Josh is again going to go over this, so you're going to hear it twice. You bend the component into, so you take a look at the board, or you take a look at wherever you want that resistor, this is a resistor, to go, and then you pick a size, you bend it to that, and then you insert it. And ideally, when you insert it, then you take those leads for a resistor and you kind of bend them out like this, so that way they're mechanically kind of secure into those holes. And you want also the resistor to be flat and in the center, in between those holes. That's the ideal. You don't want it to be sticking out or doing anything weird like that. Electrically, if you have something like that, it will work, but it's just not good practice. And also, if you have a low height on the board, it could hit something. Yeah, so just try to get them flat if you can. And if you don't, it's not the end of the world if the board is not that important. But on your final boards, you certainly should have mastered this. So the first thing you want to do is you're going to turn the iron on, wait till it's hot enough. You're going to tin the iron tip. So normally that just means you add a little bit of solder to the end of it. And then it just puts a little bit at the end. So it should look shiny. Also that I would say is not in here that I do first is typically I have a sponge nearby, and Josh is going to show you this, that has water. And also for me, I also like to have the metal, there's like this kind of metal sponge that you can get that you can also clean the tip really well. So you just don't want any crud at the crud at the bottom of the tip. You want to just be able to, I typically like get it wet on the little sponge that's wet, and then I like clean it on the metal sponge. And that way it's really nice and shiny. And then you can add some solder on the end of that if to tin it. So this is where you're going to apply the iron in contact with both the circuit board pad and the component lead. So we want to have the iron touch the pad on the board, the component lead, and then you get that hot, but not too long, but on there, you start heating that up, and then you feed the solder in. And this is an art to get this, to get these, all of this soldered in like the way this is in this picture. At the end of the day, like you want the Hershey kiss of solder when you're done. But it does take time, and it takes a lot of practice to be able to do this consistently. So I would highly recommend practicing as much as you can to learn how to do this properly. But eventually you get to a point where you can make them all consistently look really nice, and they're all electrically connected. So this is they're showing examples of good through hole solder right here. So you can see that it's kind of like these shiny leads, or shiny, the solder looks really shiny, and then you have these tips coming out. And then after you have the lead going through, you're gonna clip that. So hopefully, okay. And so before they get to the clipping, they're trying to show you a bunch of different reasons how you can do this wrong. So you see there's a lot of them. One of them is just, too much solder. I would say those kind of things right there, the too much solder and the cold solder joint, those are, you can't really tell when there's too much solder if you have a cold solder joint or not. So, and that can, basically the solder is on the pin, but it might not be touching the pad. There might be not enough solder where you're just barely hitting, there's gaps in there. Maybe you got the pad, but you didn't make enough contact for a good electrical connection. And so that kind of thing right there, it's like if the board is in one position, it works. And then if you like kind of crack the board, not crack it, but just like maneuver a little bit, then all of a sudden the electrical conductivity is gone. So it's just important to make sure that all of your solder pads have enough solder on them. And then, there's too much heat. So Josh is again going to show you examples of this. And then the worst here is the short across the two pins. So because if that is a power and ground pin, and then you've soldered like this, now you have a short across a power and ground pin that as soon as you turn the board on, it's going to short those two. So be aware, and that's why you have a current limit. So the through hole component, after you inspect it, then if the solder looks good, then you use a pair of wire cutters, or sometimes they're called diagonals, to cut off the excess lead and get as close to the board as possible. And so this is where I was saying that you really need to wear the safety glasses, because these leads will fly away and fly across the room or into your eye if you're not wearing the safety glasses. So tonight we're not going to be doing surface mount soldering, but we're going to go over it, and then you can go back to this tutorial whenever you get to that point. And we're going to be going over it more as well. We're going to be doing a surface mount tutorial at a later time. So the surface mount devices are notoriously tiny. That's what we're talking about. And once you get to these smaller level or smaller sizes, it becomes harder to see. It becomes harder to control your hand. So, but most people prefer this method of soldering once they get the hang of it. So there are two main types, which are two-terminal and multi-terminal. So when you're doing surface mount soldering, work on a clean, well-lit area. And then tweezers, you really need a good pair of tweezers for this. Less solder is more. And then coat the pad with a tiny bit. So this is, I I don't do this, but again, research this method if you're going to do it, to make sure you remove that flux properly at the end of your, if you do add flux. I tend to solder these without adding flux. But this is the packaging that a lot of them come in, and so they're stored in these strips. So you have to, like, undo the very first one of whatever it is, and then hope it doesn't fly across the room, which happens often. So make sure you always order like multiple extras of these parts, because they will fly all over your area. And then you get your tweezers out, and you have to pick up one at a time. And then on the board itself, you're going to just put a small amount of solder on the pad, like the through hole, and then and then you let it cool before you place your component on there. And then you use your tweezers, and you hold the SMD, the surface mount device, centered on the pad. And then using your tweezers, that's really important to like hold the part down. And you've already you have solder on your soldering tip, and then you have solder on that pad already. So you just go in and touch it pretty quick with the soldering iron, make sure it all flows, but it's just a real quick thing, and you are able to secure that one side down. Then it says hold the part in place even after you remove the iron. Yeah, exactly. So if you pull that tweezer away, the part will just fly away because the solder has not cooled. And so you can sit and watch solder cool. You'll see it kind of flow, and then once the heat's gone, it takes maybe 3 seconds or 3 or 4 seconds for it to cool. So if you remove your part, if you do anything where the part is not held in place, it will fly away. And then you heat the other pad slightly. And if you need to put solder on it, go ahead and put solder on it. So these little surface mount parts, because it's so quick to heat them up, you have to, before you do something on one side, make sure the other side is cooled, or else, again, the part will just go away with your soldering iron when you remove it. So this is some examples here of the good surface mount solder. So basically, when you look at the pad with the part and the solder on it, there really shouldn't be any cracks or gaps, graininess. It should be shiny, and it's just enough solder to make the connection. I almost would say that top component has a little bit too much solder for what I would like to see. But it's better than no solder, because that's a big problem. And the component is also flat. So it's not, you see that one side is not higher than the other. I think that's called tombstoning whenever that kind of thing happens. Those times it might be electrically solid, but it's not ideal, and any amount of vibration or anything on the board might knock those off. So. And then the IC chips, basically, they have a very similar thing. You tend to do one corner, you put the solder on, and then you tack the opposite side down. And you only have 2 pins, and you make sure your component is flush against the board. And it's what you want, because once you start soldering more than 2 pins, it becomes really difficult to remove that solder. And then, yeah, it's very difficult to realign it. Whereas if it's only 2 pins, you can still kind of move things and remove solder fairly easily. And then for the multi-pin surface mount parts here, it's just a very little bit of solder. And this multi-pin surface mount, that picture looks really great to me. The connections are really nice, and there's not too much solder on there. And then, but this is what can happen when you put too much solder. So just a little bit too much, or a little something not aligned with your soldering iron, then you can get a short across 2 pins. So every time you do a surface mount part, I would look at it and verify that you don't see any shorts across any pins. And if you do have a microscope, you can go put it under the microscope and as well and inspect all your pins. But normally for most of the what we call pitch, which is the distance between those leads, what we're going to be using here, it's, you should be able to visually inspect it and get a really good idea about how well you did. So whenever you want to fix the soldering errors, it happens that you get those, shorts, or you've put something in backwards or whatever. Hopefully you check that before you turn the board on for the first time. So there's several methods that you can use to fix soldering errors. And I have various luck with each of these methods. So one option is to use what's called a solder sucker, where it removes liquid solder from the board with air pressure. And so what you do is you will, you prime there's like a button on there that you tend to like mechanically push down, and it primes with like a pump. And then you heat up that component with the soldering iron, and then you push a button, you put the solder sucker right over the pin, and then you hit the button, and because the solder is liquid, it tends to suck it up into the solder sucker. So sometimes you have to do this multiple times. Make sure you always like, I tend to prime it again and then clear it, go ahead and push the button again before putting it back, that solder sucker over the board, because oftentimes that solder gets stuck inside the pump itself. And so it's a way to clean that. And then the other option is a solder wick, which is this metal braid that I was talking about, that at one time a story I heard was that it was used to connect to points in somebody's robot, and it shorted things out. So I would not recommend using this as any type of wire, even though it is a metal braid. But it's basically acts as a Q-tip that can clean up any unwanted solder. So, and Josh is going to demonstrate this, but this one is is a really good way to damage a board if you do it wrong. So if you're going to watch Josh, but then I would also recommend maybe even going to YouTube and checking out some videos before you really use this wick. What tends to happen, what I see that people do, is they use it. So you basically, I'm going to let Josh explain it, but what tends to happen is the solder iron gets removed too quickly. And so the wick will start cooling with the solder on the board, connect it to a pad. And so the wick gets pulled away, and what tends to happen is the trace on the circuit board gets pulled up with the wick, and you end up pulling up a pad on the board or a trace. And when that happens, that pad becomes completely unusable, and you can damage your entire board just by doing that. So in general, that's why it's really important to pay attention to the orientation, pay attention to how you're soldering or how you're doing that, so that way you don't have to use these methods of solder removal. But it does happen, so it's okay if it does. And then if in doubt, it's usually wiser to sacrifice the component by cutting its leads off than removing the leads one at a time. And this will avoid damaging the traces on the circuit board, which are very difficult to repair. So just what I've mentioned. Yes, you can also cut the component away if there's multiple leads. I would highly recommend.